All right, in this video, we're going to learn about multiplying polynomials, which is Module 9, Lesson 2 for my class. This is the Florida Best Benchmark AR 1.3, which is adding, subtracting, multiplying polynomial expressions with rational number coefficients. And this is the warm-up to review what we've learned in previous lessons. All right, so when we're multiplying polynomials, it's important to remember the distributive property. And when we're multiplying a term by other terms, that's when we're using the distributive property. So this works really only when you have a monomial multiplied by any other polynomial. So binomial, trinomial, but we don't like to use the distributive property when we have anything more than a monomial times a binomial or a monomial times a trinomial. So in this first example, we have our monomial, or first term, 3x squared, and it's going to be multiplied by 2x to the power of 3 minus 4. So the first thing we're going to do is we're going to take this term 3x squared and multiply it by 2x to the power of 3, and we get 6x to the power of 5. Then 3x squared multiplied by negative 4, and we get negative 12x squared. Now, don't forget your exponent rules that we learned previously, and our product rule specifically means that we add our exponents together. So notice that we did 2 plus 3 when we were thinking about our exponents and not 2 times 3, because I do see a lot of students still making that mistake from time to time. So in this next example, we have a monomial, single term expression being multiplied by a trinomial. So we're going to multiply negative 9x to the power of 3 times negative 2x to the power of 4. And remember, a negative times a negative gives you a positive, and then we're continuing to just add our exponents. So 3 plus 4. Negative 9x to the power of 3 times y is going to give me a negative 9x3 to the power of y. And negative 9x3 multiplied by negative 4x is going to give me a positive 36x to the power of 4. Now, if you struggle with distributing or you don't like to use the arrows, you can use the box method or area model, which we're going to learn to love in the next few days. And we can set up our monomial here on the outside left of our box and our binomial up along the top, and then fill in the area model. So because some students do have a tendency to forget what we're doing when we're multiplying, I broke it down step by step. So we have 3x squared multiplied by 2x to the power of 3. So I have 3 times 2. And x squared times x to the power of 3. That's when we're adding the exponents together. So when I simplify this, I get 6x to the power of 5. Then I'm going to take this 3x squared and multiply it by the negative 4. So 3 times negative 4. And then we have the x squared. So we end up with negative 12x squared. Now, of course, we end up getting the same answer as we did over here when we distributed. It's just this may be easier for some people to remember or visualize or keep their terms organized. So this is an option that you can use. All right, so here we're going to start multiplying larger polynomials. And we're going to use an area model or a box method, as some teachers call it. And this strategy to multiply polynomials is using a rectangular box that helps you keep your terms and your products organized. So a lot of times what happens once we start multiplying binomials times binomials or binomial times trinomial, students often lose products or lose terms because they forget to multiply everything. So by using an area model, we can keep track of all of our terms and everything that was multiplied. We do not use the FOIL method. In the state of Florida, actually in our benchmarks, it says do not use or teach the FOIL method to teach this benchmark. So we don't like to use it anyway, so we're not going to. So we have negative 5x squared and we have negative 7. We're going to set that up along the left side of our rectangular box. Excuse me. And then we have 4x to the power of 3 plus 8. And we're going to set that up along the top of our area model. Okay, now we have to fill in the box. And in order to fill in this area model, all we're going to do is multiply this term out here times this term up here. And we're going to remember to include our signs because our signs are very important once we try to write our polynomial at the end. So to fill in this first box, we're going to do -5 times 4 and x squared times x to the power of 3. Remember, we are adding those exponents, so we end up getting -20 x to the power of 5. Then we're going to fill in the next row. Okay, so we have -5x squared multiplied by a positive 8. And we have our x squared, so we have -40x squared, because -5 times positive 8 is a -40. Then we have -7 times the positive 4, and this doesn't have a variable, so we just have our x to the power of 3, so we end up with -28x to the power of 3. And finally, we have -7 times positive 8, and -7 times positive 8 is going to give you a -56. So we filled out and we found all of our terms. Now we're going to list the terms in degree order. So oftentimes this top left corner is our highest degree term. So it's going to be -20x to the power of 5 minus 28x to the power of 3 minus 40x squared minus 56. And this cannot be simplified any further because yes, I have the same variables, but none of them have the same exponent. So none of those terms can be combined or simplified. All right, moving on to example 4. We have a binomial multiplied by a trinomial. So we're going to take this first binomial, -x and +1, and set it up along the left side of our area model. And then we have 12x squared minus 5x plus 7 that we're going to set up along the top of our rectangular box or area model. So first things first, we're going to multiply and fill in this first box. So -x times a positive 12 is like having -1 times positive 12. So it's going to, and x to the power of 1. Remember, there's an implied 1 here, so that's why I included it here. Multiplied by x to the power of 2. So I'm going to add those exponents together, and I get a -12x to the power of 3. Now I have -x, or -1, times -5x. So -1 times -5, and x to the power of 1 times x to the power of 1. I add those two together, and I get a positive 5x squared. Finally, I have -1 times positive 7, and I do still have the x, so I can't forget that. And I end up getting -7x, because -1 times a positive 7 is going to give me a -7. Then I'm going to multiply this bottom row with times the positive 1. So 1 times 12 times x squared is just the positive 12x squared. Positive 1 times -5x, and I'm going to just end up with -5x. And positive 1 times a positive 7, and I end up with just a positive 7. Now, when I take all of those terms out, so the -12x to the power of 3, 12x to the power of 2, positive 5x squared, -5x, -7x, and plus 7, I should not end up with all of these terms in my final answer. I must simplify this polynomial. So I'm going to combine my like terms. I have a positive 12x squared and a positive 5x squared, so I can combine those to get 17x squared. -5x minus 7x, and I'm going to get a -12x. Now that I've simplified and combined all my like terms, my final answer is -12x to the power of 3 plus 17x squared minus 12x plus 7. All right, in this last one, example 5, we have a trinomial multiplied by a trinomial. That means I'm going to end up with 9 terms. And you can't tell me you're going to be able to do this in your head. So it's important that you show your work and take the time to fill in the area model so that you don't lose any terms. So we have 2x squared times 7x squared. And we have a positive 14x to the power of 4. Remember, adding those exponents. Positive 2x squared times a -1x, or -x, and we get a -2x to the power of 3. 2x squared times a positive 9, we get positive 18x squared. Negative 5x times a positive 7x squared, then we get 35x to the power of 3. But negative 5x times negative x, we get a positive 5x squared. Negative 5x times a positive 9, we get a negative 45x. 3 times 7, x squared is going to be a positive 21x squared. Positive 3 times negative x is a negative 3x. And then finally, we have positive 3 times a positive 9, and we get a positive 27. Now, when I take all of these terms out of this area model and list them in degree order, we get a 9-term polynomial. However, that's not going to be our final answer because we have to simplify or combine our like terms. So negative 35 x cubed minus 2x cubed, we get negative 37x to the power of 3. 21x squared plus 5x squared plus 18x squared, and we get a positive 44x squared. Then we have our negative 3x minus 45x. That becomes negative 48x. Of course, we have our first term and we have our last term. There's nothing to combine that with, so this is our final answer. Notice there's a pattern here. Oops. And it's the diagonals. You'll notice most of the time when we're filling in an area model, these are our like terms. So those can be combined before you take them out of the area model, as long as you don't forget a term. But look for the patterns and make sure it is a pattern before you move along. Okay? So at this point, I want you to go and work on your practice. If this is not enough room, make sure you show your work on a separate page of paper so that I know that you did this work on your own and didn't use PhotoMath. Thanks.